All right. Hello, everyone. Welcome to our official Q&A regarding vaccines. Thank you to all of the 9 viewers that we have so far. Thank you for joining us. So we are here to hear from an expert here from Loma Linda, and we will actually have our very own youth ambassadors and some youth from the Coachella Valley who will do the honors of asking some questions. And then, of course, you're more than welcome to make your questions here in the comment section or in the chat. We are more than happy to have you ask your questions, and anything is welcome. There are no stupid questions, just the ones that don't get asked. So without further ado, I'd like to introduce my hope, and he will be our today, sharing the information with us today, answering some of the questions that our youth have regarding the vaccine. Go ahead and get started with some of the questions that we have.
Sorry, you're breaking up on me. I'm not able to hear you. I think we may have a little bit of a connection issue, but maybe it's just my end.
It's actually my end, but if you could go ahead and introduce yourself a little bit, and we can get more into the question and answer.
Sure. I'm Dr. Michael Hogue. I'm the Dean of the School of Pharmacy at Loma Linda University, and I'm also one of the members of the Centers for Disease Control and Prevention's Advisory Committee on Immunization Practices work group for COVID-19 vaccines. So our work group gives recommendations to CDC on vaccine use in the United States as it particularly relates to COVID-19 vaccines. So hopefully I'll be able to share good insights with you and answer most of your questions as it relates to the vaccine. Most recently, just so you're aware, I'm a pharmacist by training, so my doctorate degree is in pharmacy, and I've been administering vaccines for about 25 years and working in this area. So happy to take any of your questions tonight about COVID vaccine and anything at all you're questioning or have concerns about. Maybe would be helpful if I just give an introduction real quickly. I know our audience tonight are primarily youth interested in the vaccine and having your questions answered. Currently, there's only one vaccine of the 3 that are approved to the U.S. market that are routinely used in individuals 12 years of age and older, and that's the Pfizer BioNTech vaccine. We usually just call it the Pfizer vaccine. But there is a second vaccine, Moderna's vaccine, that has just recently submitted their paperwork to the Food and Drug Administration for consideration of their vaccine, also to be used down to age 12. The third vaccine is by Janssen and J&J. We often call it the J&J vaccine or the Janssen vaccine. And that vaccine is approved for use in people over age 18. So we don't use it in youth primarily. So those are the 3 vaccine products that are available. And as I say, I'm happy to take your questions about anything and everything related to the vaccines. And your audio is muted there.
That's great to hear. So sorry about that, some technical difficulties, but that's great to hear. So without further ado, I'd like to introduce some of our youth ambassadors as well as the youth from the Coachella Valley to go ahead and ask their questions regarding the vaccine, because I know we are eager to have some answers here.
Hi, Dr. Hogue. My name is Senna. I'm a youth ambassador here at El Sol. So, to start off, I know a lot of people had questions, but to start off, so what are the differences between the vaccines, and can you talk about a little bit about how they work? Thank you.
Absolutely. Absolutely. That's a fantastic question. Great question. So, two of the vaccines, the Pfizer vaccine and the Moderna vaccine, actually work the same way in your body. They're called messenger RNA or mRNA vaccines. And the way these vaccines work is they take the protein from coronavirus, which is the spike protein. I'm sure all of you have seen the drawings of coronavirus. It looks like a ball and it has these little spiky things coming off of it. And those spikes are usually indicated in red color on all of the graphics and drawings you've seen on the internet and on TV. So there's a protein on the spike uh, that actually is the part of the coronavirus that causes your immune system to respond and to begin producing antibodies. And the antibodies in your body are the things that fight off infection. So, what we do with the technology for a messenger RNA vaccine, the Pfizer and the Moderna vaccine, is we take the coding for the genetic coding for that protein, and it's inserted inside of a fat or a lipid that is in the vaccine, injected into your arm, and then locally in the muscle cells in your arm where it's injected, it begins to go into those cells, and the messenger RNA for the, in other words, the code for that particular protein is reproduced in your cells, and then it elicits your immune system or stimulates your immune system to produce antibodies. And the two types of antibodies it produces are short term antibodies, and then it produces B cells or long term antibodies. And so this happens over about a 2 week period of time. So after the injection goes in your arm, it takes about 2 weeks for it to really elicit a good, strong immune response and protect you against COVID-19. We know that one shot stimulates your immune system initially and produces some initial response. The second dose that we give either 21 days in the case of Pfizer or 28 days later in the case of the Moderna vaccine then gives you longer term immunity. And so that's how that particular vaccine works. The other vaccine, the Janssen or J&J vaccine, is a single dose vaccine that we give to people who are 18 years of age and older. And this vaccine works very differently. There's a virus that causes the common cold called adenoviruses. And there are dozens and dozens of adenoviruses that exist in nature. And some of them are non infectious. In other words, they can't make you sick, whereas others give you a cold. And so we take one of those non infectious adenoviruses and we take the code for that S protein and we attach it to inside using a replacement technology. We'll replace a part of the adenovirus's DNA with the code for the S protein. And that then goes into your body, into the arm. It goes into your cell and it replicates. And again, your body produces the S protein in larger quantities, which causes your immune system to generate antibodies. And again, in the same way, those antibodies can be both short term and long term and help fight off the coronavirus in the future if you're ever exposed to the virus. So they do work a little bit differently, and that's the essence of how these two vaccine types work. Great question.
Thank you for answering that. That was really informative, and I'm sure anyone can ask more questions if they want more understanding. So, I know for the vaccines, like the thing that was preventing a lot of people from taking it was the side effects that they heard of. So, what are some of the side effects of the vaccine, and would you say they're worse than the actual disease itself? Thank you.
Good. That's a good question. Yeah. What effects are you going to have? Well, the most common side effect, which occurs in over 80% of people who get the shot, is a sore arm. And that sore arm is usually worse with the second shot than it is with the first shot. That's what we observe from almost everyone who takes the shot. It's also possible that you could feel body aches, uh, maybe even a low grade temperature, low grade fever, say 99 or 100 degrees temperature, would not be uncommon, especially after the second dose. So that's pretty common. Those are the most common side effects that we see with the Pfizer vaccine and with the Moderna vaccine. And it occurs with the exact same rate or frequency with both of those products. So one of them isn't more likely to cause side effects than the other. They're both about the same in terms of the amount of side effects that they cause of those kinds of effects. Now, there is a possibility of a more serious side effect. We're just learning a little bit about this, and that is there have been some individuals who've developed inflammation in the lining around the heart. That's called pericarditis or myocarditis, and that's inflammation in the cells around the heart or the sac around the heart. And that seems to be a response to the vaccine, where your body has an over response to the vaccine. We don't know why that happens in some people and it doesn't happen in others. It appears to be more common in men than in women. However, the incidence is still pretty low. Based on data that we saw in a presentation from the Food and Drug Administration last week, it appears that there have been about 300 cases of this that have occurred out of somewhere around 6 million doses of vaccine that were administered to individuals 12 to 29 years of age. And most of the cases that have been observed so far have occurred in individuals between 16 and 29 years of age. And again, we don't really know why it happens. We do know that so far, everyone who's had this happen has had relatively mild issues, and it has resolved on its own. There's only a couple of cases where there's been more serious concerns, and that's been followed up. So we're getting more information about this now. But going back to your question about whether or not the risks and the benefits are balanced here, um, COVID 19 is a pretty serious illness. Not a lot of youth die from COVID. 12 to 15-year-olds, for every 1 million doses of vaccine we give, we save 2 lives, but we keep probably several tens of thousands of people out of the hospital as a result of giving those doses of the vaccine. So it does save lives. And COVID is a pretty nasty infection and can have some pretty long term consequences. So the risk of having one of these serious issues with the heart is pretty low, but it's possible. And you should certainly discuss it. If you're concerned about this, be sure that you discuss this with your pharmacist or with your physician and to make sure that your concerns are addressed before you get the vaccine. But for most everybody, the only effects that you're going to have from the vaccine are a sore arm and possibly some body aches, chills, and a low grade fever that'll last about 2 days from the time you get the vaccine, and then you'll feel fine.
Thank you. That was a very good comparison, and it's definitely something people need to consider. One more thing, when you were talking about the antibodies for the COVID-19 vaccine, so is there like an expiration date of like the immunity of the vaccine, and will there need to be boosters, or is it a more long-term thing? Thank you.
That's a great question. I think we all really do want to know the answer to that question, but we don't know the answer to that question entirely just yet. because the vaccine's relatively new, we only, we're monitoring people that receive the vaccines as part of the clinical trials. And we're still less than a year from the time the first persons were enrolled in the clinical trials and we began monitoring. So we really don't know yet how long you're going to have protective immunity against coronavirus. What we do know is that there's a type of antibody that your body produces called a neutralizing antibody. Neutralizing antibody is just like the name sounds. It neutralizes the virus when it's in your when you're exposed to it. We want those neutralizing antibody titers to be as high as possible because we know the higher they are, the greater the likelihood that they're going to immediately prevent you from getting the infection or getting sick with the virus from the virus. So we want to keep those neutralizing antibody titers high. So we're watching that very closely to see how long your neutralizing antibody titers stay high and how long your immune memory lasts, so that even if your neutralizing antibody titers are not high, that if the virus were to show up, that your body would switch on and say, hey, I recognize this, and begin producing the antibodies again very quickly in order to stop the infection. So the answer to your question is we just don't know yet. We do not know yet how long the vaccine is going to work, and we don't know how long, whether or not you're going to need boosters. We do know that both manufacturers, Moderna and Pfizer, have predicted that you may need to have a booster shot, but we don't have enough scientific evidence yet to make a definite determination about whether boosters are going to be necessary. It would not surprise me if that is determined necessary, but we just don't have enough information yet to know. So stay tuned. It's possible that you may have to have an annual booster. We will certainly keep everybody very informed on that. For right now, the most important thing everyone can do is to get the two-dose series and get that initial protection as soon as possible.
Got it. Thank you. I want to move on a little bit about the other factors with COVID. So I know there's a lot of other variants coming in, especially the Delta variant from India and other countries. Do we know if the vaccine provides immunity against that, or is there not enough research done on that?
Well, actually, we do have a pretty good bit of data that's mounting about the vaccine's ability to protect against the variants. The good news is that the vaccines do, in fact, appear to provide good protection against the variants. I'm speaking specifically about the Pfizer and Moderna vaccines because those are the vaccines that are most likely to be used in youth. We have a little less information about the Janssen vaccine in some cases with some of the variants. Um, However, the Pfizer and the Moderna vaccine so far appear to do a good job at preventing you from having any kind of serious infection from one of the variants. Why is that important to mention? Because, you know, whether or not it prevents a find the right words. Whether or not it prevents you from having what we call asymptomatic infection, which means you're infected, you just don't know it because you don't have any symptoms. With the variants, that's still not yet well known. We don't do a lot of nasal swab studies right now to be able to know if that's the case. What we look for is whether or not people who get sick actually wind up in the hospital or worse, like die. And if the vaccine can prevent us from having serious infection, then we consider that a success. And so far, what we know is the vaccine is very effective, even with the variants, at preventing individuals from being hospitalized or dying from COVID. So, very important to do that. And the other thing I want to mention to you, since we're on this topic of variants, there are going to be a lot of variants over time. And the way that we can stop variants in their tracks is to not have a host for the variant to be able to replicate in. So the way viruses produce variants is that they find a host that they can reproduce in, and you have two types of viruses that come together and exchange their genetic material, or they mutate over time in hosts that are able to not fight off those viruses. Well, the way that you stop that from happening is that you get the vast majority of the population protected against that with their own antibodies so that they can fight off the infection in the first place. So we look to achieve something we call herd immunity, and you've probably heard a lot about this on the news. And what that means is that the vast majority, 75 plus percent of our population, becomes immune to the virus through vaccination or through having been infected with COVID themselves. And once we reach that threshold, it becomes very difficult for the virus to find hosts to be able to replicate in. And so then we reduce our risk of having variants happen. But we've got to achieve that globally. It's not enough for us to achieve that just in the United States because these viruses circulate globally, and COVID 19 is a pandemic. Pan means across, pandemic means that this is an outbreak that's occurring all around the world. So we have to be very diligent to ensure that we have vaccine access in every country around the world so that we can eliminate the possibility of the coronavirus having a host to replicate in. And then hopefully we can shut down these variants as well, and we'll be less concerned about those. I hope that was a helpful answer.
Yeah, that was very helpful and very informative. Thank you. Would you say that the variants and the COVID further mutating is getting more deadly than it was currently?
Well, I'm not so sure it's getting more deadly necessarily. We're not seeing um, death rates increase tremendously in the countries where vaccine is highly active, but we are seeing hospitalizations go up in countries like India, where the vaccination rate is very low. We've not got a very high vaccination rate at all in India, but you're talking about the world's second most populous nation. And so vaccine access has been a problem in India from the very beginning. So we don't have a lot of people that are immune, and the variants can spread faster sometimes than the original coronavirus, and that's what we see is a more rapid transmission and easy spread of the virus, and that can lead people to develop more serious infection quicker. So yes, we do see increased hospitalization, and of course, coronavirus is a deadly virus regardless of the mutations. Some of the mutations do cause a higher rate of death than others, and some of the mutations are roughly the same as the original COVID.
Got it. Thank you. So just to clarify for everyone watching, so the vaccinations will lead to herd immunity, which will prevent other variants and mutations from occurring, correct?
Yes, they will certainly slow down or stop the ability of the virus to have a host to mutate in. So, getting everybody vaccinated is important. I think it's a really important message to hear, too, that I know, I have daughters that are 18 and 21. Both of them have been vaccinated against COVID. And, most of their friends say that they have a hard time understanding why it is important to get vaccinated because most youth don't get terribly sick. I mean, most youth feel bad for several days, might not, may feel very tired when they get coronavirus, but not necessarily get the serious infection with respiratory problems that winds them up in the hospital. Um, will say that youth that have asthma or diabetes or kidney disease or something like that do have a much higher risk of being hospitalized and having problems. So many times you feel great and you're healthy and you're working out all the time and you're doing all the right things with diet and exercise. And you may say, well, why do I need to worry with this vaccine? I'm not going to get sick. Problem is that you can actually carry the virus and spread it to people who can get very sick because youth are very social. You guys hang out together all the time and you're in each other's homes and you see each other's parents and grandparents and you engage in the community. And the chances are that if you contract coronavirus while you may not get sick, you may spread that virus to a lot of other people, and some of those people likely will get very sick, and it's possible that some of them will die. And so, part of the reason why we get vaccinated against infectious diseases is not just to protect ourselves and to take care of our own bodies, but it's also to protect those who are around us and those that we interact with. Some of those people that we interact with may not have a fully functioning immune system, and they might get very sick if they were to contract the virus. So, it's a responsible thing to do to get vaccinated, not just for your own personal health, but for the health of people you interact with every single day, whether it's your friends' families or grandparents, or whether it's at the grocery store or at the movie theater or the restaurants or Disneyland. So it just is a good idea to get vaccinated.
Thank you for mentioning that. I think that's a very important message for all the youth and their parents watching, and hopefully this clears more things up for them. I don't know if Lorena had any more questions, but we can move on to the effects after, or the rules you should follow after you get the vaccine. So I know a lot of people, the mask mandates are going on in California. So do you need to wear a mask after you are fully vaccinated? And how long do you reach immunity after you get the vaccine? Thank you.
Good questions, very good questions. It usually takes about 2 weeks after your first dose of the vaccine to begin producing enough antibodies to protect you against the infection. Um, because it's a two-dose primary series with the Pfizer and the Moderna vaccine, it's going to take you another 2 weeks after the second dose to get your antibody levels up to where you're going to have 95% protection against the virus. So you're looking at from the day you get your first dose of vaccine until the day your body has full immune protection with the Pfizer vaccine. That would be a total of about 5 weeks from the day you've gotten your first dose. So 3 weeks between your two doses, and then another 2 weeks after that before you have your full immunity. So that's how much you're looking for the Moderna vaccine. You're looking at about a 6 week process because it takes a week, but there's a week longer between those two primary doses before you're going to have that full 95% protection against the virus. So that's about how long it takes. And I think there might have been another part to your question, but that's the answer to how long it takes before you get immunity.
Okay, perfect. I don't know. I do know we have a couple other youth joined with us here. Lorena, will you be able to? Uh, are you able to connect here to see if you have a question here?
Yes, I do have a question. I have a question, and is and it is: do you see the possibility for you to fully return to in-person courses since the vaccine is currently available this academic year?
That's a great question, and the answer is definitively yes. I believe that we will return fully to in person learning. Um, as you probably are aware, just yesterday, California announced a full reopening. and return to normal activities. And so I believe that, especially as our vaccination rates continue to go up and more people get vaccinated, we have a better and better chance every day of resuming in person learning. I know here at Loma Linda University, we're already back in session and in person. Our classes are face to face again. We're looking forward, even in the fall term, when we have even more students on our campus, that everybody's going to be face to face and our classes are going to be face to face. I know my daughter is attending UCLA this fall, and she's also in face to face classes this fall, according to UCLA. And I expect that that's going to be true at all of the high schools around. I know that the high schools in San Bernardino County, most all of them have now announced that they'll be face to face in the fall. So I think it's a very positive development. I think that the more people that get vaccinated, the better the chances are of staying in a face to face environment, and preventing any outbreaks from happening in the fall. So, again, it's just another reason to get vaccinated, is so that we don't have to wind up in this, what I call Zoom fog, where everybody has just really been tired of being online and on Zoom all the time. So, get vaccinated so that we don't all have to go back to that.
Thank you. I have one more question. What if you get COVID after the first dose of vaccine? I know that that could discourage individuals to get the second dose. What would you tell them?
Yeah, so the first dose, as I said, does not kick in and provide the 95% protection. You know, the Pfizer vaccines and the Moderna vaccines have been found to be 95% protective against COVID, but that's only after two doses, and that's only 2 weeks after the two doses. So you got to have enough time to pass by. It's still possible to have a person who's received one dose come down with the virus after that one dose because they haven't yet had both doses. In fact, I know a couple of individuals that have had that happen. They got their first dose, and before they could get their second dose, they actually came down with COVID and were sick with COVID. So it is possible for that to happen. We still encourage people to have their second dose of the vaccine, but we will say that you should probably wait some longer period of time before the second dose. But don't be discouraged. It doesn't happen frequently. Breakthrough infections happen, but at a very, very low rate. And then, of course, people who have those breakthrough infections tend to not be nearly as sick as they would have been had they not had any doses of the vaccine.
Thank you. I have one more question. What do we currently know about the new vaccine, Novax? Uh, what would you say to the youth or to parents that are currently
Well, I know about as much about the Novavax vaccine as you can find in the media right now. They have just submitted a emergency use authorization to the U.S. FDA. There is nothing that has been, the detailed scientific data around their study has not yet been released. So I haven't had time to actually analyze it myself to look into all of the details. The high level data says that the vaccine is very effective, about 90% effective at preventing coronavirus, but I haven't seen all of the details. I still don't know at this point if Novavax even intends to fully market the vaccine in the US right away, because the global need for vaccine is so much higher at this point. And we currently have enough doses of COVID vaccine in the United States to offer every person who wants a vaccine the vaccine. So there's still a lot of question as to even if the FDA approves ultimately the Novavax vaccine, we're still not even sure that Novavax will decide to market it and release it into the U.S. market. I wouldn't make any strong bets right now on the Novavax vaccine being available in the U.S., and I certainly wouldn't wait to get vaccinated for that vaccine to come to the U.S. market because it may never actually come to the U.S. market, or at least not in the short term. It may be many, many months. So, my encouragement to all of you is to get vaccinated with the available product that's available for your age group as soon as you have the opportunity. And vaccine is so easy to find now. It's not hard to find a place to get vaccinated. You can go to of course, any medical center like Loma Linda to get vaccinated. You can go to your doctor's office. Most doctor's offices now offer the COVID vaccine. And you can go to your local pharmacy. Just about every pharmacy on every corner has COVID vaccine. So there's all kinds of options available to you. And usually you don't even have to have an appointment to get a vaccine. You can just walk in and say, hey, I've decided I want to get my COVID vaccine, and you can get vaccinated. So that just would encourage you to not put it off waiting for another product to come to the market.
Thank you. I have one more question. Are there any medications that can interfere or cause a worsened reaction to the vaccination? If it could be if you're allergic to a food allergy or something like that.
Yeah, so there's no medicine that we're worried about an interaction with the vaccine. So it doesn't really matter what other medications you might be taking at the time. We're not worried about that with the vaccine. What we are concerned about is that if you've ever had an anaphylaxis reaction, which anaphylaxis is a serious reaction that usually involves your ability to breathe. And let's say that you've had a bee sting or some reaction to a food product that caused you to stop breathing or have to go to the emergency room because your respirations were not optimal or you were having trouble breathing. That anaphylaxis we worry about not because you're definitely going to have a reaction with the vaccine, but people who do have an anaphylaxis reaction to the vaccine most typically have had anaphylaxis to something else in the past. So it doesn't mean that you'll have that reaction to the vaccine, but what it means is that you need to have a healthcare provider like a nurse practitioner or a pharmacist or a physician or a physician assistant monitor you for 30 minutes after you get the vaccine so that they can provide medical assistance in the event that you do have that kind of a reaction. It's very, very rare for that kind of a reaction to happen. But it is possible. And so it's more possible in people who've had that happen before with either a food or an environmental allergen.
Thank you so much for answering all my questions at the moment. Thank you.
You're welcome.
You're muted, Jonina. Sorry.
Oops, sorry. Thank you for that. Sana, do you have any last minute questions that you wanted to ask before we close up here?
Yeah, I know. I'm 18, and a lot of my friends were asking me. So, and they were wondering, should we still be wearing our masks like next year and after we're vaccinated? I know like the restrictions are going down, and should we still be like social distancing? How is that like working?
If you're vaccinated, there's really no reason for you to wear a mask. And that's the new CDC guidance. That's also California's guidance as of yesterday, is that fully vaccinated people do not need to wear masks. You're not going to carry the infection and you're not going to catch the infection. It's very highly unlikely. It's not 100%, but highly, highly unlikely. So being vaccinated will give you freedom from masks. Right now, the state of California is going to require K through 12 students when they return to class to wear masks, whether you're vaccinated or not vaccinated, when you're in the classroom. That, however, could very well change by the time we get to school starting back. And the thing that could cause that to change is that if enough youth get vaccinated, then the state could reverse its decision on wearing masks and say, okay, we've got a large enough percentage of our youth vaccinated that we don't need them to wear masks. So the key message there is really get vaccinated and encourage your friends to do it. I know it's beautiful sunshiny days, you go out to the beach and it's exciting and you don't think there's no care in the world. But we got to start working now to get ourselves vaccinated and fully protected before we go back to school in August. And that's really important that we take that action right now and not wait until August to do it. Do it now. And that way you're fully protected when school starts back in August and you don't have to think about it. And that can put us in the best position of not having to worry about masking and social distancing. And that's what I would encourage you to do. So, should you mask and should you social distance? If you're vaccinated, the answer is you do not need to worry about those things. If you're not vaccinated, then you do need to worry about those things. You are at risk of catching the virus and you're at risk of transmitting it to other people. So, you're going to have to do those things.
Got it. Thank you so much for taking your time out, Dr. Hogue, and answering all of our questions. I know we all really appreciate it, so thank you.
It's my absolute pleasure to do it. Glad to do it.
Well, thank you all so much for your time. We appreciate all our viewers here on Facebook, all 11 of you. So thank you for taking the time to watch. I do know Melina had some closing words to share with us. So Melina, the floor is yours.
Thank you, Joanina. It is wonderful to hear all the youth asking these amazing questions. So I appreciate you, the ICA team, and ELSO for providing those questions. Thank you, Dr. Hogue, for joining us this evening and giving us the opportunity to ask those questions as well. Thank you, Joanina, for the introduction and hosting this webinar. And I appreciate all your hard work and efforts with the team as well. My name is Melina Wilson, and I'm the Community Outreach Coordinator for Loma Linda University Children's Health and NDO, and also for the Institute Community Partnership. And we want to welcome you to our next webinar, which will be next Wednesday, same time at 5:30. This will be a Spanish webinar. And also, if you have any questions in the meantime, you can reach us at ELSO's Facebook page or Instagram, or you can email me at melinawilson@llu.edu. Thank you.
Thank you all so much for tuning in. Of course, if you have any more questions, they're more than welcome to go into the chat, and we will work to get those answers for you. Thank you all, and I hope you have a wonderful evening.
Thanks. Bye bye.
Thank you.